Okay, let's start today permutations and combination discussion. So, first of all, I will just revise combination part. Here you consider n distinct objects, are to be selected. Then we do this selection by NCR. R factorial, n minus r factorial, r factorial. That's how we do. That is very special. N distinct objects. N distinct object R selection NCR. And there can be equal coincident things. So you consider A double P L E. So here we have two P letters, one A letter, two P letters, one L letter, one E letter. Let's say we need to select three of them. Then three selection can be done, two equal, one different. Because here we have two maximum and three different. That's how we select. Okay, two equal, one different and three different. We have that case. Then here two equal, we have one group, no? Then select that 1C1, take that group. Then if you select this one, then there are three remaining. To get one different, here three, take 3C2, 3C1. Then three different, we have four cases, take 4C3. Then that's how we select. Then here selections. 1C1, 3C1, 4C3. Select 3. Then arrangement of three characters. Here selection, then arrangement. Then further arrangement of 3. Further you have to analyze that. Now here we have 3, 1C1, 3C1. Now we have 3. Then you arrange 3 factorial ways. Here we have 2 equality. Then to remove that equality, divide by 2. Here 4C3. Now we have selected 3. You arrange them 3 factorial, divide by. Here we don't have any equality. No? Then here total arrangements. Here total arrangement. Here total selections. Okay, let's start from that. Okay. Then first you write about this combination. Okay, first write this. So I gave this before, but you just write and take this example. Then you go to that example. Okay, then write examples. Here selection of three characters. Here arrangement of 3 characters. Okay. Now come to 2013 A-level question. 2013 A-level question. First read it well. 2013. Read it well first. Take a little time to analyze it. A student council of 15 students consisted of 3 science students, 5 art students and 7 commerce students. It is required to select 6 students from this student council to work on a project. Find the number of different ways in which this can be done. First one, all 15 students are eligible to be selected. Second one, 2 particular students are not permitted to work together. 2 students from each of the subject stream need to be selected. Also find the number of different ways in which a group selected under tree, seated around a circular table. Take little time. Think about selections. Think about selections first. Yeah, there are 15 students. 15 students, consider 3 science students, art 5, 7 commerce students. It is required to select 6 students. Select 6. Find different ways in which this can be done. If first one, all 15 students are eligible to be selected, then all are distinct now. Then we have to select 6. 15C 6. Second one, 2 particular students are not permitted to work together. So 2 of them are not permitted to work together. Therefore, from all you have to remove when they are working together. Then 15, 6, 6, all. Then 13, 3, 2, 4. 13, C, 4. Then you specially select those 2 and there are another 13. 13. By this 13 you select 4 and add with this. Then they work together. Then 13C form in both of them working together. Then if you remove, now they are not working together. When they remove, then they are not working together. Then here second one. Then 2 students from each of the subject stream need to be selected. Then third one, by science we have to select 2. By arts you have to select 2. By commerce you have to select 2. Here it is. Simple question. Then each of the group have to select 2 by 2. Then thereafter find the number of different ways which the group selected under tree can be seated around the table. Now circular arrangements. So here in this case circular arrangement. So when you consider n circular arrangement, n distinct. Circular arrangements we call n minus 1 factorials. Here n minus 1 factorial, circular arrangements. Now here we have selected 6 students. Here this case, now here we have 6 students. We have to arrange 6 students around the table. 6. Then always 6 minus 1 factorials. 6 minus 1 factorials. If we have n distinct students, we have to arrange along a circle. Then altogether we have n minus 1 factorial ways. Therefore, here 6 students, 6 minus 1 factorial ways. And further given that if 2 students from science stream in the group are not permitted to sit next to each other, then science students not permitted to sit together, then you take these two as one unit. Now here 2, 4, 5, 6. Now here we have 6 students. Here 2, 3, 4, 5, 6. 6 students. Now we have 5 units, no? 1, 2, 3, 4, 5 units. Then 5 minus 1 circular arrangement, no? 5 minus 1 factorial ways into their arrangements 2 factorial ways. Then here they sit next to each other. Then we need to remove them. Here they sit next to each other. Then here the required arrangement. Then here 5 factorial minus 4 factorial into 2 factorial. Here the thing. Okay. If you need to arrange next to each other, you take as 1 unit. Okay. Take as 1 unit. Then if you take as 1 unit, here we have altogether 5 units. Then circular arrangement 5 minus 1 factorial. 5 minus 1 factorial. Then we can swap them. We can swap. Then 2 factorial ways, another arrangements. Then here, this case, they sit next to each other. Here total case, then when you remove this, then they are not next to each other. That's how we select. Now try 2011, 2012. 2011 and 2012. 2011, 2012 questions. Start it. Okay, 2011 permutation question. Here given digits 1, 2, 3, 4. If repetitions of digits are not allowed, first one not allowed, so we have to make a number. We have to make a number. That means line arrangements. So here the number in between 2000 to 4000. 2000 to 4000, no? Then here first digits will be 2 or 3. If you put 1, it is 1000 thing. That not happen. Then if you put 4, then it is 4000 thing. So we have to make a number 2000 to 4000. Then to fill first space, here first space now. To fill first space, here we have 2 or 3. 2 or 3 we can put. Then 2 ways. Then the remaining 3 any. So if you put 2, now we have 3 digits to arrange here. So remaining 3 spaces, arrangement 3 factorials. 3 factorials. Okay. If we have n distinct object line arrangement without repetition, just n factorials. No? N distinct objects without repetition, line arrangement n factorials. N factorials. Then we have 3 conditions, n distinct objects, line arrangements without repetition, 3 ways. Okay, 3 steps. Now here this case, there is special condition within 2000 to 4000. Therefore, we have to select first space first, then 2, 3 must be selected for this. Then to fill first space, we have 2 ways. So if you take 1, then remaining 3 must be arranged here. Remaining 3. Now here these 3 must be arranged on a line without repetition by taking all at once. That is 3 factorial ways. Then total ways 2 times 3 factorials. 2 times 3 factorial. Here 12. Here without repetition. If the repetitions allowed, here 3 spaces to fill first space. Now further we have 2 fill first space. Here we have 2 ways. Then next 3. Now repetitions allowed. Here for this space we have 4 options. Here we have 4 options, and for this again we have 4 options, and next space we have 4 options, 4 to the power 3. Then total, when the repetitions allowed, you say 2 times 4 cube. 2 times 4 cube. Okay? You can simplify this now. So 2000 to 4000, we have to first select first digits. That must be 2 or 3. Therefore, to fill first space, we have 2 ways. Then if the repetition is not allowed, then 3 factorial ways have to arrange here. Then altogether 2 times 3 factorial. If the repetition is allowed, anyway, first space we have 2 distinct ways. You put 2 ways. Then remaining 3, then we have repetitions allowed. Then here we have 4. We have 4 characters, then 4 ways. Here 4 ways. Then 2 times 4 to the power 3. In permutations, theorem number 1, n distinct object line arrangement without repetition by taking all at once n factorial ways. Theorem number 2, n distinct object line arrangement by taking all at once with repetition, n to the power n. Theorem number 3, n distinct object taking r at once, line arrangement without repetition, npr. Then fourth theorem, there are repetitions allowed, n to the power r. Fifth theorem, remove equality, n objects, r of m are same, then n factorial divided by r factorial. Then to remove equal, we have divide by that factorial arrangements. Then sixth theorem, circular arrangements of n object, n minus 1 factorial ways, n minus 1 factorial ways. Then clockwise sense, only clockwise sense, n minus 1 factorial over 2, anti-clockwise sense, n minus 1 factorial divided by 2. Then combinations, n object R selection we say NCR. Then those are theorems that need to analyze under permutations and combinations. Yeah, 2011 question complete. Okay, then 2012. Here there's word given ADDING, add in A1, D2, I1, N1, G1. In how many of these arrangements? Find the number of arrangements that can be made using all letters of the word add in first. Okay, then here all together we have 1, 2, 3, 4, 5, 6. So we have equal to here. To remove that one, divide. So now next case, in how many of these arrangements the vowels are separated? So vowels are separated. So vowels A and I. You take as 1 unit. Here take as 1 unit. Here 1 unit. Now we have 2, 3, 4, 5 units. 5 units. When you swap them 2 factorial ways, now here vowels together. Vowels together. Then all arrangements 6 factorial, 2 factorial. Here we have equal to, then divide by 2 factorial ways. Then here second case, vowels are not together now. Here take vowels are together, take 1 unit, then all together 1, 2, 3, 4, 5 units, arrange them 5 factorial ways. So we can swap them 2 factorial ways. Then there are 2 equal to here, remove it. Then here vowels together, vowels together. Then here total, by total remove vowels together, then vowels are not together. Vowels are not together now. Okay, then 2012. Okay, then you come to 2016. Two 2016 and 17. Take time. Okay, then 2016 question. In how many different numbers with 5 digits can be made from the digits 1, 2, 3, 4, 5? Each of these is used only once, that means repetition is not allowed. How many these numbers are even and 3, 4 next to each other? How many different numbers with 5 digits can be made? Now here 2016, here 1, 2, 3, 4, 5 digits we have. Then without repetition, total arrangements 5 factorial, no? So we have 5 distinct objects to be arranged along a line without repetition, 5 factorial ways. Then even numbers. Now first case even. Then to get even numbers, here last digits must be 2 or 4. Then last digits, last space, 2 or 4. So we have two ways. No? So if you select one, we have 4 to be arranged again. First four arrangements. Then we have 4 factorial ways, no? 4 spaces, 4 factorial ways. Then last digits 3 or 2 or 4. Therefore, total even numbers 2 times 4 factorial. 2 times 4 factorial. Then here repetition is not allowed. Then if the number is even, then you had to think about last digit. That must be even digit. Okay. Then you arrange it first. Thereafter, initial digits can be different one. Then you arrange all the other 4. Then thereafter, first you arrange last digits. Then you arrange thereafter the remaining part. Then next case, have the digits 3, 4 next to each other. 3 and 4 next to each other. 3, 4 combination or 4, 3 combinations, both possible. Then you take 3, 4 together. You take 3, 4 as one single unit. 1 unit. Then second case, now we have 1, 2, 3, 4. Arrange them. We can swap it 2 factorial. Then 3, 4 next to each other. 3, 4 next to each other. 4 factorial into 2 factorial ways. 3, 4 next to each other. Okay. Then next to each other, stay together. They are not together. All we consider by taking them as one single unit. Okay. Then go to 2017. First you identify whether it is combination or whether it is arrangement. So arrangement means there can be line order and or circular order. Both possible. Okay, continue. Okay. Now 2017, let's do that. Here there's a word given, infinity. Infinity. In how many different ways can 8 letters of the word infinity be arranged in a row? Then first count them. I letters 1, 2, 3. N letters 1, 2. F letters 1. T letters 1. Y letters 1. We have to arrange them in a row. In how many different ways can the 8 letters of the word infinity can be arranged in a row? Okay, then here 3, 5, 6, 7, 8. So we have equal to 3 and 2. Remove them. Okay. How many of these arrangements have all 3 I letters cross one another? Then I letters together. Then you take I letters together. Take this one as single unit, 1 unit. Now we have 1, 2, 3, 4, 5, 6 units. We have equality only 2. Here first part. I letters together. So we don't have any further I arrangement together. All I are same now. Then if 2 distinct objects, we have to multiply by 3 factorial. For 3 distinct objects, we have to multiply by 3 factorial. But here all I letters are same, therefore no need to think about further arrangements. Then here I letters together. Second one, exactly 1 I letter and N both letter are first 3 letters. Then you select 1 I, then this will be 2. And both N letters, you have to arrange in first 3. Then here first 3 arrangement. First 3 arrangements. Here we have 3 spaces, 3 letters, 3 factorial equal to 2 factorial. Then here first 3 letters. Then further we have next 5 letters. Then remaining we have here 1, 2, 3, 4, 5. Then 5 factorial ways. We have 2 equality, 2 factorial ways. Then here first 3 arrangements. Here we have I, N, then 3 factorial divided by 2 equal to remove. Then next 5 we have Y, T, F and 2I. Then 5 factorial divided by equal to, there are 2 now, 2 factorials. Then here first event, here second event, now you combine by multiplication. No? Then total will be here 3 factorial divided by 2 factorial times 5 factorial divided by 2 factorial. Here total arrangements. First 3 I, N. Thereafter next arrangements. Now write this correction, then later we can go to past paper again. Write this correction. Find total line arrangement and circular arrangements. Find total line arrangement and circular arrangement of the letters given below, of the letters given below. Okay. Here A, B, C, D, do with me. Line arrangement 4 factorial, circular arrangements 4 minus 1 factorials. Here line arrangement, circular arrangements. Here 5 factorial, 5 minus 1 factorial. Then distinct objects. For distinct object, then total 5 factorial ways and 5 minus 1 factorials. No? Then for all cases same. Then 10 incidents. Here 10 factorials, 10 minus 1 factorials. Circular arrangement 10 minus 1 factorials. For distinct object you can do that way without repetition. Here 1, 2, 3, 4, 5, 6. Then here 6 factorial, 6 minus 1 factorial. 6 minus 1 factorial. Okay, next question. Find different numbers. Find different numbers which can be formed by taking the following digits. By taking the following digits. By taking the following all digits. By taking the following all digits at once without repetition. Without repetition. First one, how many of them are even? How many of them are odd? First one, how many of them are even? How many of them are odd? How many of them are multiple of 5? How many of them are multiple of 5? How many of them are multiple of 5? Okay, you start. Okay, start it. Take time. Okay, now here 4 digits, 5 digits, total numbers 5 factorial. Then even numbers 1, 2, 3, 4, 5. Here last digits must be 2 or 4, no? Here 2 different ways. Then remaining part you arrange 4 factorial ways. Here even numbers, even 4 factorial and 2. Then odd mean balance 5 factorial minus 4 factorial times 2, no? Here not 2 factorial, it is 2. 2 factorial දැම්මත් මෙතන අවුලක් නැහැ. හැබැයි 2 කියලා තමයි එතන දාන්න වෙන්නේ. අපි count කරලානේ ගන්නෙ. last digit 1 2 කියලා count කරලා ගන්න. එහෙනම් 2 factorial දැම්මත් answer ගෙනවා. හැබැයි 2 දෙකක් තමයි දාන්න ඕනේ. odd. Then here 2 4 5 6. Then all 4 factorial even 1 2 3 4. Then last space here 2 4 6 all 3 possible. Then 3 ways. Then remaining if you put 1 then we have 3 factorial ways. Then 3 factorial times 3 even. Then odd balance 4 factorial minus 3 times 3 factorial. 3 times 3 factorial. Okay. Then here multiple of 5. Multiple of 5. 1 2 3 4 5. Then last this must be 5, no? So we have one ways, last space. Here one possible ways. We have to put only 5. Okay, multiple of 5 means last digits must be 5. Then 5. Then all the other 4 you can arrange in 4 factorial ways. 4 factorial times 1. Here multiple of 5. Multiple of 5. Then here multiple of 5. Arrange spaces 1 2 3 4 5. Sorry, 4 spaces. Then multiple of 5 we had to put 5 here. Then here we have only one possibility. One possibility. Remaining 3 arrange 3 factorial way. Here multiple of 5. 3 factorial times 1. Multiple of 5. 3 factorial times 1. Make බැරි වෙලා 5 කියලා දැම්මේ ය. 5 digit එක දානවා. 5 digit එක දැම්මට අපි count එක එකයි එන්නේ. To fill last space one possibility. One possibility, remaining 3 arrange 3 factorial ways. Then all cases we don't repeat the things. Okay, repetition is not allowed. Here this is somewhat special. So here these two cases 0 not there, but there we have zeros. So when making numbers we can't put 0 at the beginning. When making numbers we can't put 0 at the beginning. Then for 0 value not possible as the front element. Then here total numbers 1 2 3 4 5. Then first space we have 4 possibility. We have 4 possibility. Then remaining 4, when you put this one we have 4 now. You can arrange 4 factorial ways. Then total numbers here 4 into 4 factorial. 0 impossible as the first digit. Then these two cases no need to worry about that. No need to worry, but that case 0 we can't put at the beginning. That's why first space we have to think. First space we have 1 2 3 4 possibilities. So if you put this one we have remaining 4. We have remaining 4 arrange 4 factorial way. Okay, your total numbers. Okay, then even further we have to think. First do up to that. Okay, now let's analyze it properly now. So when making a number 0 can't put at the beginning. Okay, when making a number 0 can't put at the beginning. Here 0 1 2 3 4 we have 5 digits. 5 digits now. Here we have 5 digits. Now, even numbers, even. For even case, last digit 0, 2, 4 possible. Are possible, no? And because of 0, can't put at the beginning. At the beginning. 0 can't put at the beginning. And last digits must be 0, 2 or 4, no? We have 2 special cases. Now let's see. First you put 0 here. Put 0. 0. Then you fix 0 here. Then you arrange all the other. Here we have 4 spaces now. Then arrange all the other 4 factorial ways. Then this is even. 0 at the end. 0 at the end. Here 4 factorial ways. They are even. Now you take the other 2. 2 or 4. 2, 4, 0. Sorry, 2 or 4. Here last digit 2 or 4. Here 2 possibility. Then here further we have 4. 1, 2, 3, 4. Then if you put 2 or 4, say you put 2 here, then remaining here we have 0, 1, 3, 4. 0, 1, 3, 4 we have. But we can't put 0 here, no? Then we have remaining 3. Here first space. First space. Okay. Then next 3 spaces, we have to arrange the other 3. We can't put 0 here. No? Then 3 factorial way. 3 factorial ways. Now last digit 2 or 4. Then beginning we haven't put 0. Then it is even. Then total even 4 factorial plus 3 into 3 factorial into 2, no? Total even numbers. Then if we have 0, then we have to think lot. Huh? So we can't put 0 at the beginning. And also even you have to think about last digits. So first you fix 0 here, then it is even surely, and 0 not at the beginning. You arrange other 4 factorial ways. Then last digit you take 2 or 4, put it here 2 ways. Then first digit we can't put 0, then we have 3 possibility. Then remaining 3 we can arrange anyway, 3 factorial. Then first digit not 0, last digit 2 or 4, that means that is even. Then sum mean even case. Sum even case. Then here even, then odd mean odd. Odd case balance. Therefore odd. Then total 1 කලින් ගත්තනේ 4 into 4 factorial. Subtract addition. 4 factorial plus 3 into 3 factorial into 2. Here odd values. Okay, do up to that. Now multiple of 5. Multiple of 5. Here 1, 2, 3, 4, 5 digits. Then to get multiple of 5, last digit 0. No? We don't have 5 there. No? Then here if you fix 0 here, surely that is even or that is multiple of 5. Multiple of 5. Then you fix 0, the remaining 4 arrange 4 factorial ways. Then here multiple of 5, 4 factorial ways. Just only 4 factorial ways. Okay, now let's move to past papers again. Let's move to past papers again. Okay, 2021. Take 2021 read and start it. 2021. Okay, first read and start. Okay, 2021. Here there are, it is required to 4-digit number form. It is required to form a 4-digit number consisting of 4 digits taken from 10 digits given below. 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 4, 5, 5. Then 1 digits, here 1, 3, 2, 2, 3, 2, here 4, 1, 5, 2. Then likewise that character arrangements. Then here find the number of different 4 digits numbers that can be formed if all 4 digits chosen are different. All 4 digits chosen are different. Therefore, you have to select 4 groups first. Select 4 groups 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5. 5 groups. 5 groups, you select 4. 5 C 4. Then you arrange it 4 factorial ways. Okay. We have 5 groups 1, 2, here 1, 2, 3, 4, 5. 5 groups, select 4. 5 C 4. Then by each you take 1 by 1, 1, 1 you take. Thereafter arrange them. Now here 4 digits you arrange 4 factorial ways. Arrange 4 factorial ways. Second one, if any 4 digits can be chosen, any 4 digits can be chosen, then here 3 equal cases. Because of that, here 4 can be chosen, 3 equal, 1 different, 2 equal, another 2 equal. Then 2 equal, 2 different, all 4 different. Likewise, we can classify them. Okay, we can classify. So because of this one, we can select 3 equal, 1 different, or 2 equal, 2 equal, 2 equal, 2 different, all 4 different. So we have to select group here. To select 3 equal, there is one group, 1C1. So if you selected this, we have remaining 1, 2, 3, 4 groups. You select 1. Then 2 equal, another 2 equal. We have 1, 2, 3, 4, 5 groups. So 2 equal, another 2 equal. We have 1, 2, 3, 4 groups. 4C, 2 select. Then 2 equal, 1, 2, 3, 4. Select 4C1, select one group. Then if you selected this, we have 1, 2, 3, 4 groups. Select 1. 2 different, select 2. Then 4 different, all 5 C4. 5 C4. That is group selection. Okay. Then thereafter we have to arrange digits. Thereafter have to arrange digits. Then here multiply by 4 factorial. Here 3 equality, remove. Multiply by 4 factorial. Here we have 2 equalities, 2 and 2. Multiply by 4 factorial. We have 2 equality. Multiply by 4 factorial, no equality. Then finally you get addition. Finally get addition. Okay, first you group them. First you group them and analyze. Here you group each of them. Because of this maximum tree, 3 equal 1 different possible, 2 equal another 2 equal possible, 2 equal 2 different possible, all 4 different possible. Then you have to select first group. You select group, and in that group you take the relevant count. Okay, by that group take the relevant count. Okay, then you go in this order. Twenty 2023, 2020, 2018, 20. Okay, continue. I'll give you a little time to start. Most of them are combination type, and some of them are further permutations have. Start. Okay, 2019 question. Here P1 set A B C D E A B C D E 1 2 3 4 1 2 3 4. P2 set F G H I J 5 6 7 8 5 6 7 8. Now here 3 sets. So all characters are distinct, all letters, digits are distinct, then all are distinct. Then 2 different sets, each set distinct element, and when you consider all are distinct, Now it is required to form a password consisting of 6 elements. Have to make a password by 6 element. You have to select 6 element. 6 element password by considering U1 P1 union P2 by taking all ones, no? 3 different letters, 3 different digits. Then 3 letters, 3 digits. Then here 6 element, 3 letters, 3 digits. In each of the following cases, find the number of different such passwords can be formed. 6 elements are chosen only from P1. Then 6 must be selected from P1. Here password means arrangement, no? Line arrangement. So you have to select, then thereafter arrange. Select and thereafter arrange. All 6 elements are chosen only P1. Then first case, here there are 5 digits. 5 digits, you select 3. 5 letters, you select 3. 4 digits, you select 3. Thereafter we have 6, arrange them. 5 digits, select 3. 5 letters, select 3. 4 digits, select 3. Then all 6 have, then arrange them, line arrangement without repetition. First one. Second one, 3 elements are chosen from P1 and 3 elements are chosen from P2. Then 3 from P1 and 3 from P2. Okay. Then here, second case, let's make a table P1, P2. Here, letters, digits. Here 5 letters, 4 digits. 5 letters, 4 digits. Okay, take this table. Then from P1, 3 take. Then let's take 3 letters and take 3 digits. Or you can swap it. 3 digits, 3 letters. Okay. Then 2 letters, 1 digits, 1 letter, 2 digits. Okay. Then 2 digits, 1 letter, 2 letter, 1 digit. Do we have another combination? No, because P1 we need select 3, no? By P1 need to select 3. P2 need to select 3 again. Then no any other combination. Now here this one, 5C3, 4C3. Here 4C3, 5C3, then twice into 2. Then 5C2, 4C1, 5C3, sorry, 5C1, 4C2, 4C2, then 5C1, 4C2, 5C2, 4C1 times 2, no? Then take addition. Then total, take addition. Thereafter we have to arrange, no? 6 factorial ways into 6 factorial ways. So after selection, you have to arrange. After selection, you have to arrange. Huh? Then finally, total arrangements, total passwords, total 5C3, 4C3 times 2 into 6 factorial plus 5C2, 4C1, 5C1, 4C2, 6 factorial times 2. Then full addition will be the required answer, full addition. Okay. So you better take a table and see possible combinations. Okay. Get a table and see possible combinations. According to that, you do arrangement. Okay. That is 2019. Okay, then go to 2023. 2023. Read and start. Okay. Then 2023. Let's do 2023. Here, a committee consisting of 4 men, 4 women. Four men, 4 women is to be selected from group of 8 men and 8 women. Then all 8 men, 8 women. Eight men, 8 women. Sorry, 6 women. 6 women, okay? Find the number of different ways in which the committee can be selected, then without any restriction. Then 8 men have to select 4, 8C4. Then 6 women have to select 4, 6C4. Multiply. Okay, simple. Then second one, suppose that such a committee was selected. That committee was selected. Find the number of different ways in which those committee members can be seated in a row of no 2 women can be seated next to each other. Okay. Now we have taken for 8. We have taken 8 now. 4 men, 4 women. No? Suppose that committee was selected. Find the number of different ways in which these committee members can be seated in row if no 2 women can be seated next to each other. Then first you seat men. Here M1, M2, M3, M4, 4 factorial ways. Okay. Seat men. Here 4 factorial ways. Now here we have spaces. Here 1, 2, 3, 4, 5 spaces we have. Then those 5 spaces we can put women, no? Those 5 spaces we can put women. You have to select 4 first, then put 4 women. Then 2 men can be seated next to each other, but only 2 women cannot be seated. Therefore here 5 spaces, then 5 P4. Then take 5 and you select 4, arrange. Then first men arrangement 4 factorial, then women arrangement within 5 spaces 5P4, 5P4. Or otherwise you can do this way. Okay. First arrange men, then you select here 5 spaces now. Select 5C4, select 4 spaces. Now we have 4 women, arrange them. It's also possible. Huh? Both are same. 5P4, 5C4 times 4, all are same. Then simple, very simple question. But explain, na? Step by step you have to explain. Here selecting 4 men out of 8. Then selecting 4 women out of 6. By counting principle, 8C4 times 6C4. Likewise you have to explain it. Then here this case, first arrange 4 men 4 factorial ways. Then 5 spaces, then select 4 spaces 5C4 and arrange women 4 factorial. Then total ways by counting principle 4 factorial into 5C4 into 4 factorial. Likewise you have to explain it. Okay, same time go to 2000 question before 2020. Go to 2000 question. So you have to do 2020, but before that you do 2000 question. Not 2000, 2001 question. Na? 2001 question. Question. In how many ways 7 boys and 7 girls be lined up? If girl must be first and girl and boy alternate positions in a line. Girl, boy, alternate position, start with girl. Start with girl. First arrange girls. Then arrangement of girls. We have 7 factorial ways. Then first girl, then we don't have any space here. Now we have 1, 2, 3, 4, 5, 6, 7 spaces to arrange boys. First must be girl, then before that we don't have any space. Then within these 2 girls we have spaces to arrange boys. Arrangements of boys. So we have 7 boys, we have 7 spaces. Then 7 factorial ways. Total 7 factorial into 7 factorial. Now boy girls are alternate positions. Boy girls are alternate positions and start with girl. Start with girl. Okay, let's do 2020. Take time. Okay. 2020. 2020. It is required to select musical group consisting of 11 members. So there must be 11 members from among 5 pianists. Pianist 5, guitarist 5, 5 pianists, 5 guitarists, 3 female singers, 3, and 7 male singers. 7. So you have to select 11. And here there's condition. There's condition. That 11 exactly to must include 2 pianists. Exactly 2 pianists. 2 pianists. At least 4 guitarists. 2 pianists, at least 4 guitarists. So at least 4 guitarists mean 5 guitarists possible. At least 4 guitarists mean 4 guitarists possible, 5 guitarists possible. Find the number of different such musical group can be selected. Okay. Then you have to select exactly 2 pianists. Here 5, no? You select 2. 5 P2. Here exactly 2 pianists. Then here guitarists need at least 4, no? You select 4. 5 C4. Now we have 4 guitarists. Now balance we have 7, 10, and here remaining guitarists you put the other pool. Then 7, 10, 11. 11. By that 11 you select remaining part. Then 6 we need 5, no? 11 C5. 11 C5. Select 2 pianists, exactly 2. Then select 4 guitarists. Then remaining guitarists you put the other panel, other pool. Then female singers 3, male singers 7, 1 guitarist balance. Then altogether 7, 3, 10 and plus 1, 11. By that 11 you take here, still we have 6, we need 5. By that 11 you select 5. Then in that combination there can be 5 guitarists or 4 guitarists. Okay, here it is. And further, find also the number of musical groups among these having exactly 2 female singers. Having exactly 2 female singers. Okay. Now you select 2 pianists first. 5C2. Let's take pianist, guitarist, female singer, male singer. Then 7, 3, 5, 5. So you have to select 2, no? 5C2. Then at least 4 guitarists needed. At least 4 guitarists needed. Then 5C1, 5C4. Then need exactly 2 female singers. You select 2 female singers, 3C1. Then up to now we have selected 4, 2, 6, 7. Then here we have 7 male singers and 1 guitarist remaining. Then altogether we have 8. By 8 you select here 6, 7, need 4. 8C4. Do you have any other combination? No. That's it. Exactly 2 pianists must be selected. At least 4 guitarists must be selected. Here 3C2, no? 2 female singers must be selected. 2 female singers must be selected. Then 4, 2, 6, 8. Then here we need 3 only. We need only 3, 8C3. with the condition do selections. ඔයාලට මේ කම්බිනේෂන් එකත් හරිය. බලා ගන්න මේ කම්බිනේෂන් එක. 2 pianists 5C2. 4 guitarists 5C4. 2 male female singer 3C2 and balance 8යිනේ 3 7C3 male singers plus at least 4 guitarists ne, then 2 pianists 5C2, then 5 guitarists 5C5 and 2 female singers 3C2 and 7, now up to now 9 ne, then 7C2 male singers. 7C2 male singers. Both combinations can be get. එකත් okay. 1 pianist, 4 guitarists, 2 female singer, 3 male singer. 2 pianist, 5 guitarists, 2 female singer, 2 male singer. Both possible. මෙතෙන්දි මම ඒක 8 කරගත්තාම මේ දෙකම එකට සෙට් වෙනවා. ෆයිනල් ආන්සර් එක එකම වෙන්න ඕනේ. Okay. Let's have small interval.